Okay, so hi everyone, welcome to the new lesson. So today will be the first lesson for chapter 4. So we'll be covering the part for discrete random variable in two lessons, which is today's one and Friday's one. And after that, we'll see how the progression of the what is that called MCO and how's the arrangement of our semester 1 exam, then we decide whether we will continue the syllabus or not. Okay, so alright, yeah, so but don't need to worry for that part, so try to focus on what you can do, like what is within your locus of control. So just try to like make sure that you do your exercise, do your study, then make sure that you are learning on your own. Okay, alright, so today's lesson, the learning outcome will be how to draw up a probability distribution table relating to a given situation involving discrete random variable and calculate the expectation of x and the variance for x. So I'll be splitting this learning outcome into two lessons. So for today it's mainly on probability distribution. Then for Friday it will be how to calculate the expectation and the variance. Alright, okay. So before we jump into the content itself, so I want to like do some introduction because this is like a totally new chapter for you also. So I would want you to like understand what is that mean by discrete random variable before we move into like how to calculate the probability. Okay, so you have your own notes here, then later you are going to like put something, you are going to like do hands-on together when I teach here. So make sure that you fill in the blank here, and other than that, then you can read through the notes again after my explanation. Okay, so the first thing is what is random variable first. So before we talk about discrete random variable, so a random variable is basically a variable that takes a numerical value as a result in an experiment. Okay, so the concept seems like very vague, so let's try to look into one example, then you will see it like much more clearer. Okay, so number one, so this is just an example here. Okay, so suppose that we are about to toss a fair coin for 2 times, and you need to record how many number of hits then you can obtain here. Okay, so you see for this experiment, what is the outcome that you are interested to know? So in this case, you want to record the number of hits that you can get when you toss the fair coins 2 times. Okay, so in this case, the number of the hits is basically a random variable that will eventually take a number, because what is the outcome that you can have? So like your number of hit. Okay, because the question wants you to like record your number of hits, right? So what is the possible outcome for your number of hit when you toss the fair coins 2 times? Maybe you didn't get any hit, right? Which is 0. Maybe out of the 2 times you are getting 1 times hit, so that's why 1. And also you can get 2 times hit also. So do you able to get a 3? No, because you only toss it for 2 times. So the maximum for the number of hits that you will be obtaining is like 2 only. So that's why the number of hits will be 0, 1 and 2. Okay, so these are the outcomes from your experiment. So you can see your experiment, what is the type of value that you have. It's like 0, 1, 2. So they are a numerical value. So that's why this is a random variable. Okay, so under random variable, right, look at your notes. We have actually 2 types of random variable. It's the same like for your data also. So we have discrete random variable. Then the second one, we have continuous random variable. So discrete random variable is the content that we will be dealing with in this chapter. And then after that, for continuous random variable, we will be looking at it in the next chapter. Okay, so but I'm just going to do a very brief introduction today so you understand what are you doing then. How do you distinguish between these 2 types of variable, so you know that which approach you should take when you see question like this. Okay, so what is discrete random variable? Discrete random variable can take only certain value, or in another word, you can take only an exact value. in an experiment. So for example, number of darts thrown until it hit the target. So you need to throw the dart until it hit the target. So maybe it cannot be 0, right? Like without throwing any dart, then you cannot say that you have like you try 0 darts until it hit a target. So the minimum will start with maybe 1. So maybe 1 time you can hit the target, maybe 2 times then you get the dart hit the target, or maybe you fail for the first 2 times, then you get it for the 3rd time, and even 4 or any infinity. But for this one, what is the exact value that you can take here? It's like all countable number. So meaning like 1 dart, 2 dart, 3 dart, 4 dart. So it cannot be like 1.358 dart. So it's all countable number. So okay, maybe let's see the second one. The number of subjects a selected student takes in A-level. So maybe he will be taking only 1 subject, maybe 2 subject, maybe 3 subject. So maybe you have a maximum here. I'm not sure, maybe like the 5. Okay, so 1, 2, 3, 4, 5 are the exact value that can actually occur when you want to find out what is the number of the subjects the students take. So all this number is exact value, but don't get me wrong here, an exact value can be a decimal. So for example, if I want to find how much profit can I earn in a month, okay, so maybe you will be getting something like okay, let's not use that example. Okay, yeah, I want to find out what is the price of a pen sold in a shop. Okay, then maybe I can have like one of the shop sold it like 1 ringgit and 20 cents. Then maybe I can have 150. Then maybe I can have like another one like 750. So you can see this is all like exact value. So you can say that like it's 120, it's 150, it's 750. I cannot say that it's in an interval. Okay, so that one is called as discrete random variable. So let's look at continuous. So for continuous random variable, right, your values is lie in an interval. So for example, when we talk about height, so height of a random selected students in college, so it can be like maybe, yeah, okay, so what is the interval in this height? So it might be like greater than 0, correct? So you cannot have someone that have a height of 0 cm. So you can accept things like 161.5 cm, or maybe in the interval then you can have like 173.85 cm. Like anything that is within an interval you can accept it. So like mass of a random selected textbook, okay, so maybe we say that the maximum of the mass of the textbook is like 10 kg. So what is the mass? The range will be like in between, let's say if this is y, then it can be your y must be greater than 0, but it will be always smaller than 10 kg. Okay, so this is the interval that you can accept your data be in. So it is not like an exact value. Okay, so that is continuous random variable. Okay, so now let's look at the example that we have just now. Okay, so for this one you can see that the probability that you are having, right, is basically 0, 1 and 2. So this is very obviously is a discrete random variable. Okay, so now let's look at this one. So you want, for this question, right, what you want to do is you want to record the number of head. Okay, so that's why the discrete random variable in this question is basically the number of heads. Okay, I repeat again. So you want to record, or you want to find out how many number of the heads, right? So that's why the discrete random variable in this experiment is basically number of heads. Okay, so now let's try to assign a variable for this. Okay, so maybe let's say we put like x. Okay, so let x be the number of head. Okay, so from what we have done just now, then you know that the possible outcome for the number of head will be like either 0 head, 1 head, or 2 head. Okay, now we try to find out what is the probability for everything to happen. Okay, so yeah, you need to like do some revision for the probability that we have actually learned in chapter 3. Okay, let's say in this case, so what are the possible outcome for a fair coin when you toss it for 2 times? So you can have, okay, I'm going to write here possible outcome. So make sure that you write inside your notes, okay? Okay, so what's the possible outcome? Maybe you get 0 head, so meaning the first one you get a tail, the second one you also get a tail. Maybe you have the other possibility that the first time you get a tail, then the second one you get a head. Then you can have the next one, the first one you get a tail, the second one you get a tail. Sorry, get a head and then get a tail. Then the last one, maybe you will get 2 head. Okay, so for all this outcome, what is the number of x here? Okay, so maybe here I'll try to put it value of x. Okay, you see, let x be the number of head. So what is the value of x? Do you have any head here? No, so 0. So th, do you have any head? Yes, 1 head, right? So 1. ht, how many head that you have? 1. So how many head that you have here? 2. Okay, so this is the value of x. So meaning we want to, when you record the number of head, this is what you will record. Okay, so what is the possibility? Okay, so let's try to find it out. Okay, so this is TT, right? So when you toss a fair coin, then what is the probability for you to get a tail? Is 1/2. For head also 1/2. So for tail, then meaning is 1/2 times 1/2, which gives you 1/4. Okay, the same thing, head and tail, then you're going to do 1/2 times 1/2 also, which gives you 1/4. Same thing go for head and tail. And then for head is going to be 1/2 times 1/2 also, which is 1/4. Okay, alright, now we want to group it into a more summarized table. Okay, because the question wants us to like write down what is the relationship or what is the probability when we try to, because you see this is not organized enough because you have 2 value of x here. So we try to combine these 2 together. So let's try to move on for a new table here. Okay, let's say my value of x. Okay, so what is the possible outcome that I'll have? I'll have 0, 1, and 2, correct? Then after that, what is the possibility? Okay, so now we try to refer to the table above, then we try to come out with the answer. Okay, so for 0, what is the possibility or what is the probability here? It's like 1/4, correct? So 1/4. Sorry, I should be writing per probability. Okay, probability. Okay, then after that for 1, you can see for th you get 1 head, ht you also get 1 head, so you have 1/4 and 1/4, so you plus them together will give you 1/2. Okay, so for you to get a 2 head, then you have a probability of 1/4 also. Okay, so you can see for this graph, right, for this table that I have actually built here, this is actually called as probability distribution. Okay, so what is probability distribution? So probability distribution is basically a listing of all its possible value of x and the corresponding probability. So you see, the possible value for my x is 0, 1, and 2, which is all the possible value, right? I do not have like 3, 4, and so on, because the maximum number of head I can obtain from this experiment is basically 2. So that's why my possible value will be 1, 2, 3, and I will list down all the corresponding probability, which I have done here: 1/4, 1/2, 1/4. So this one, what is this called? This is basically called as probability distribution. Okay, so normally for probability distribution, we will be trying to do this in a table form, or we will try to do it in a function. So maybe sometimes you will have a lot of like possible value for x, so it's like impossible for you to write everything in a table. Then for that, particular situation, we will try to use probability function for that. Okay, so this is basically a table. Okay, so how do we describe all the data here? So normally we will use a method of px equals to x. Okay, so how can we do that? So let's say, move up a bit. Okay, so what is 1 over 4 mean? 1 over 4 is the probability for x equals to 0, which is 1 over 4. Okay, what does that mean? Your x is number of head, right? So in a very easy interpretation, then how do you read this? It's basically the probability for the random variable, the x meaning the random variable, in this case, which is the number of head. The probability for the number of head equals to 0 is 1 over 4. Okay, so in the same way, I can say that probability for the number of head to be 1 is basically 1 over 2. So same thing, probability for the number of head equals to 2 will be equals to 1 over 4. Okay, this is what it means. So, but of course, this is just a variable, so you can use anything that you like x, y, z, a, b, c, anything, as long as you assign in your question. Okay, so normally, what is this? Then this is basically our small x. Okay, the probability here is basically our probability when x equals to x, so which is 0, 1, 2. So normally how do we assign? Then we will write in the way that px equals to x. Okay, so the small x is basically what is the possible value for your random variable, which is in this case 0, 1, 2. So this is all your small x. The big X is the one that you assign, so meaning the number of head in this case, then probability. Okay, so when you read it, then it will be like, what is the probability when your random variable is equals to 1, when your random variable is equals to 2, when your random variable is equals to 3. Then of course you can put like greater than, smaller than also. What is the probability when your random variable is greater than 0, and so on. Okay, so for this is basically called as discrete random variable, and this is called as probability distribution. Okay, so for all discrete probability distribution, they must satisfy two things. So the first one is all your probability is just same like what you have learned in chapter 3. You do not have any probability that is negative. Your probability will be like in the range from 0 to 1, which is like impossible to happen, certainly will happen. Then as higher as your probability, the most likely the event will happen. Okay, so the first one is the same thing. All the probability must be greater than 0 and smaller than 1. So which you can see in the all value here, you actually get that. Then the other one is that the sum of all your probability for your random variable will be equals to 1. So in this case, you can see 1 over 4, which is 0.25, plus 1 over 2, 0.5, plus 1 over 4, which is 0.25 also. When you plus them together, you get a 1. So this is when like, it's the same thing like when we say a complete picture for a probability, the sum of the probability for an event will be equals to 1. Okay, so I hope that you can like grab the idea for what a random variable is. Then after that, we'll move into like some like 7 examples together. Then we are done for this lesson. Okay, so now let's move on for some example here. We will try to go through everything together. Okay, so number 1, 2 dice is thrown and the sum of the score of the 2 dice are recorded. Show the outcome with the sample space diagram. You should know how to do this already. So let y be the sum of the score and find the probability distribution for y. Okay, so you want to find out the sum. So I hope that you still remember how to use a sample space diagram to do that. Okay, so maybe let's write down the outcome first. So again, for this question, I try to like draw everything out for you. So but in the exam that there won't be any, what is that called, the layout for the table is given. I just want to make it like convenient for you, but I just did it for question 1. So the other one you need to use your ruler and build your table yourself. Okay, so yeah, let's try to do this. You already know how to do, so I'm just going to do this very quickly. So what is the outcome for the 2 dice? It can be 1, 2, 3, 4, 5 or 6. So same thing, the second dice can have an outcome 1, 2, 3, 4, 5 and 6 also. Then let's try to write down the sum. 1, 1 you get 2 and 3, 4, 5, 6, 7. So everything plus 2, you get 3, 5, do I do something wrong? Sorry, 4, 5, 6, 7, 8. So same thing, everything plus 3, 4, 5, 6, 7, 8, 9. Okay, everything plus 4, everything plus 5, everything plus 6. Okay, so this is how you get a sample space diagram or probability space diagram. Okay, so now we need to write down the probability distribution for y. Okay, so what is your y? Your y is the sum of the score. So what is the possible outcome that you will get for y? So look at this one. These are all your sum, right? So your first possible outcome for y, the smallest one will be 2, correct? You do not have any possibility for your sum to be 0 because the minimum value for the dice is like 1, 1. So it's impossible for you to get 1 also because the minimum is like 1 plus 1, which gives you 2. So that's why 2, then you have 3, 4, 5, 6, 7, 8, 9, 10, and then up to 11 and 12. Okay, so now you can work out, so you still remember how to write this. So probability for big Y equals to small y. Okay, oh, I'm sorry, this one should be a small y. Okay, then you need to write it down. Okay, so when a small y equals to 2, so probability when the sum of the score is 2. So how many you have? 1 and over 36. So 1 over 36. Okay, so the second one, probability when your sum of the score is equals to 3. You have 2 here, which is 2 over 36, which will gives you 1 over 18. Okay, for probability when the sum of the score is equals to 4. So 1, 2, 3, which is 3 over 36, which is 1 over 12. Okay, for 5, you have 1, 2, 3, 4. So 5 over 36. Okay, so probability when your sum of score is equals to 6, which will gives you 1, 2, 3, 4, 5, 6. So 6 over 36, which is 1 over 6. Okay, then I'll do for 7, which is 6 over 1, 2, oops, sorry, 1, 2, 3, 4, 5. Meaning I did something wrong here. 5, 1, 2, 3, 4. Okay, this should be 4, so this should be 1 over 9. I'm sorry. Maybe I try to do this, then it will be. Okay, then easier, yeah, because I counted the 5 and 6 outside just now. Okay, then after that, I try to do the same thing, continue. 7, 1, 2, 3, 4, 5, 6. So 6 over 36, which will gives you 1 over 6 also. 1 over 6. Sorry, this is 36. Okay, then after that, for 8, the probability for your y, for your sum of score equals to 8, you have 1, 2, 3, 4, 5. So 5 over 36. Then same thing, you do it for 9, you do it for 10, and you do it for 12, 11, and then 12. Okay, So after you build a probability distribution table, right, so it will be helpful that what you can try to do is you try to add everything together and check whether you get a 1 or not. So if you didn't get a 1, then you might need to check it back, like any of the process you did something mistake or like some careless mistake here and there. Okay, so try to make sure that you use a calculator to calculate, like plus them all together, so and see whether it fits or not for the condition for a discrete probability distribution. Okay, so that's it. Then after that, find the probability when the sum of the score is greater than 10. So probability for the sum of the score is greater than 10. So basically, what is the probability that you need? Greater than 10, so meaning 11 and 12. So probability when y equals to 11 plus the probability when the sum of score equals to 12. Okay, so for this probability, you have 1 over 18 plus 1 over 36, which gives you an answer of 2, 3, so 1 over 12. Alright, okay, so you can see actually what are we learning now, right, is the same thing like what you have learned in probability. It's just that we try to do it in a distribution way in a table to show every outcome. So if let's say I change the whole question, I only give you like 2 dice. Okay, I change this question to like 2 dice is thrown. Find the probability when the sum of the score on the 2 dice is greater than 10. Then you will do the same thing also. Then you will try to find out like greater than 10. Then you might have like what are the things that you have here. So like 1, 2, 3. So 3 over 36, which will gives you 1 over 12 also. So this is basically the same thing, but you try to organize everything in a more systematic way. And the outcome that you can have is only like numbers. Okay? So let's try to do a second one. The probability when the sum of score is greater or equal to 4. Which for this case, you need everything here, right? Equal or greater than forming everything here. So instead of like plus everything here together, then what you can try to do, you minus off the part that you don't want, since you already know the sum of the probability here will be equals to 1. So that's why equals to 1 minus probability y. The part that you don't want is like y equals to 2 and y equals to 3. Okay? So 1 minus 1 over 36 minus 1 over 18, which gives you the answer as 11 over 12. Okay, that's it for number 1. Okay, so let's move on for number 2. X is a random variable with probability distribution given. Find the value of C. So you can see this is like probability when the random variable is equals to 2, you get 0.05. When the random variable is 3, you get C power 2, then 4, and so on. Okay, so how do you solve this? Yeah, so you still remember there's a law in your discrete probability distribution say that the sum of all your probability must be equals to 1. So that's why we can plus them all together and they should be equals to 1. So if you want to write it down, then you can write down the sum of the probability when x equals to x, it will be equals to 1. Okay, then you can try to write down probability when x equals to 2 plus probability when x equals to 3 plus probability when x equals to 4 plus probability when x equals to 5 plus probability when x equals to 6, it will be equals to 1. Okay, then now we try to substitute all the value inside. 0.05 plus C2 plus C plus 0.1 plus 2C plus 0.05 plus 0.16 will be equals to 1. Then you can see this like this is a quadratic equation. So we try to organize everything. So you get C squared plus 3C minus 0.64 equals to 0. Then we try to eliminate the decimal. So we try to move everything like for 2 decimal place or like multiply by 100 plus 300C minus 64 equals to 0. Then you can start to do your factorization and you should be getting 5C minus 1, 5C plus 16 equals to 0. So which C is equals to 1 over 5 and negative 16 over 5. Okay, so in this case you have two answers, so you need to check and see whether these two answers are accepted in this question or not. So you check it out, what is the condition that you need to check. So you still remember all your probability should be within the range for 0 and 1. So that's why when you have like 1 over 5, then you check like everything 1 over 5 square, 1 over 5 plus 0.1, then you substitute 1 over 5 here plus, then you get everything positive. So you know 1 over 5 plus. So the other one, 16 over 5, when you change it into fraction, then it will be 3.2. Okay, so negative 3.2. Negative 3.2 square, then get a positive is fine. But when you reach here, right, you see negative 3.2, when you plus 0.1, you still get a negative number, which is negative 3.1. So in this case, this one cannot be accepted because the range is not, I mean, it doesn't satisfy the range that we want. So that's why in this question, you might need to write it because of the probability for your x should be between 1. So that's why your c must be equals to 1 over 5 only. Okay, so please remember, it's not because of your c must be positive, it's because the c, when you substitute inside, your probability must be smaller than 1 and greater than 0. It cannot be a negative number, so that's why we choose c equals to 1 over 5. Okay, so move on for number 3. Okay, so number 3, given that a discrete probability function, yeah, so you can see this is a discrete probability function. So for these two questions, this is like all probability distribution table, which I see the first method of display. So this is a table, this is a table also. So you can also use a probability function, which is what is shown here. Okay, so number 3. So given this is the function, then find the value of k. So this question is very similar to number 3. It's just that you need they are not shown in a table form. Then you need to find out all the corresponding probability by yourself. Okay, so since probability, so maybe you can write it down first. Probability for x random variable equals to r is equals to kr, given that r equals to 1, 2, 3, 4. Okay, so if they give you 1, 2, 3, 4, meaning that the max they can accept is 4, the minimum they can accept is 1. So meaning anything out of that, then you are that is not in your possible outcome. It's like the same thing like we have done for the in the example section. So we have only 0, 1, 2. So you are not going to look at all the infinity number. Okay, yeah. Okay. Yeah, there's an example in number 4. You will see here that anything here like they put a dot dot dot, meaning that the number of your possible outcome will go to infinity. Okay, so let's try to look at this. So it's the same thing when you want to find the value of k, then what you need to do is use the idea of all the probability. When you add up together, then you should get 1. Okay, so sum of all the probability x equals to r should be equals to 1. Okay, so now what is the discrete random variable that you have? 1, 2, 3, 4. So meaning probability x equals to 1 plus probability x equals to 2 plus probability x equals to 3 plus probability for x equals to 4 will be equals to 1. Okay, then now you can try to substitute. So when x equals to 1, meaning that the r here become 1. So that's why the r here also become 1. So that's why when you substitute 1 here, then you get a k. Okay, so p when x equals to 2. So when x equals to 2, r here become 2 also. So it become 2k. So the same thing for 3, then it become 3k and 4k. So all this plus together, then you should be able to get a 1. So k plus 2k plus 3k plus 4k, you get 7, so 10k equals to 1. So that's why k equals to 0.1. Okay, pretty easy, right? Okay, number 4. So this is another probability function also. So you can see like this is the what is that called, the number, the exact value that it can accept. Okay, so A, write the probability that x equals to 1, x equals to 2, and x equals to 3. So what you try to do is just substitution. It's like equation, okay? So probability when x equals to 1. So equals to 1 over 6 times 5 over 6, then 1 minus 1. Okay, so this one basically equals to 0, then you get a 1, so 1 over 6. Then continue, probability when x equals to 2. So 1 over 6 times 5 over 6, then this one you have 2 minus 1, which gives you 1, so 5 over 36. Yeah, okay, so move on for the next one, probability when x equals to 3, which is 1 over 6, and then 5 over 6, and here you have 3 minus 1. Okay, so 3 minus 1, you are getting a square. Then after that, when you count it with your calculator, then you should be able to get 25 over 216. Okay, alright, so B, find the probability that when x greater or equal to 4. So you can see that I want to start from 4, and then I want to find out what is the probability for anything like 5, 6, 7, 8, 9, 10. I want to plus them all together. But in this case, you do not have infinity or like a limit for your exact value here, so you can accept anything here. So it's pretty impossible for us to find. But so what you can find out is, instead of finding the probability for x greater or equals to 4, then you try to use the total minus the probability when x smaller than 4. Okay, which is you use 1 minus probability of x equals to 2, sorry, x equals to 3, x equals to 2, and x equals to 1. Okay, then I try to, it's basically what you have found here lah. Then we try to put everything in. Okay, then you'll be able to get your answer 125 over 216. Okay, alright, number 5. A scout patrol consists of 8 members. 3 members are King Scout. If 2 members are selected at random from the patrol and Z represent the number of the selected members who are King Scout, then show that Z is a discrete random variable. Okay, so the idea of how do you show that it's a discrete random variable is you need to show that when all your probability, you plus them together, you will be equals to 1. Okay, so how are you going to do that? Then maybe you try to assign it first so that you can like see this question in a clearer approach. Okay, so Z is number of selected member who are King Scout. Okay, so in this question, right, maybe you can try to write down first what is the exact value that you can accept here. You are going to choose 2 members. So out of the 8 members, which 3 members are King Scout. So what is the possible outcome that you have? So your Z, it can be when you select the 2 members, it consists none of the King Scout, correct? Because I have 8 members, then only 3 of them are King Scout. So I might have the possible outcome that I get 0 King Scout. So maybe I can have one King Scout also, or I'm like very lucky I can get like 2 King Scout here. So these are the possible value or the exact value that I can accept in my random variable. Okay, so these are the numbers. So now you need to find out for everything for that when you want to build a table. So we start from the probability when the number of the member King Scout is 0. Okay, so you imagine if you don't want to have anyone to have King Scout, then meaning that, what does that mean? So yeah, you can have different approach here. Okay, the first one is like if you want to use a combination. So for this one, they are going to select, so the arrangement doesn't matter. So of course you have combination. Okay, so if you want to use combination, then what you can do? So like you want to get none King Scout, so like 0 King Scout. So meaning the 2 person that you are going to select are from the 5 people who is not King Scout, correct? So that's why you have 5C2. Is that okay? I'm going to choose 2 from the 5 scout that is not king scout. Okay, then divide by, what is the total value here, is 8C2. Okay, so like, yeah, you still remember for the sample space is the probability or the condition that you do not have any restriction. So that's why without any restriction, it means from the 8 you are going to pick 2. Okay, so 5C2, then you have 10. So 8C2, then you have 28. Okay, which gives you 5 over 14. Is that okay? Alright, if you don't want to use this, what you can try to do is you try to do probability like yes, no, what is that called, use independent effect, because you can try to draw a head diagram, then you try to find out the first one not a king scout, then the second one not a king scout. So meaning that if you don't want to do this, then what you can try to do is pz equals to 0. So meaning I do not want to get any king scout, right? So meaning that I want to get a non-king scout and a non-king scout. So for the probability for me to not get a king scout is going to be 5 over 8. So after I have choose the first one, then I left with 4, then choose it out from 7. So that's why when you have 5 times 4 and 8 times 7, you will get the same thing also, which is 1 over 14. So depends on you which one you want to use, is totally fine. Okay, so the next one for z equals to 1. Okay, so if you want to choose exact 1 king scout only, so meaning that what are you going to do? From the 3 king scout, you are going to select 1. So after that, from the non-king scout, you are going to select 1 also, then divide by 8C2 also. Okay, which is the one that without any restriction. So this will be 3 times 5, which will give you 15. Okay, and then divide by 8C2, which is 28. Okay, so you have 15 over 28. So if you don't want to do this, then what you can try to do is you try to find out probability when z equals to 1 is equals to probability when your first one is king scout, second one is not king scout. Or if you want to do this case, you must make sure that you have the other round, which is probability when the first one is not king scout and the second one is king scout. Okay, so you will be using 5 over 8 times 3 over 7, then the other one is 3 over 8 times 5 over 7. Okay, I just write it here lah. Okay, the first one king scout, so meaning it will be 3 out of 8. Then you choose 1 already, then you left with 7, so the non-king scout you still have a 5. So plus the other one, it will be non-king scout first, so 5 over 8 and then times with 3 over 7. Okay, so you can try to check it out, you should get the exact same answer also. Okay, so the last one, when you get exact 2 king scout. Okay, for you to get the 2 king scout, meaning that from the 3 king scout you are going to pick 2, then from the non-king scout you are not going to pick any, so you can put down 5C0, or you don't want to put it as, it's just 1 lah, okay? So divide by 8 over 2. So this one will give you 3C2, which is 3. Okay, 3 over 28. Okay, then it's the same thing. If you want to do this, then it will be probability for z equals to 2, meaning it will be the probability when your first one is a king scout, second one is a king scout also, which means 3 over 8 times 2 over 7, and you will get 6 over 56. And when you simplify, then you should get the same answer. Okay, alright, so just like that. Then after that, yeah, not finished yet. The question wants you to show that z is a discrete random variable. So you need to do this. Probability when your z equals to small z, okay, is equal to probability when z equals to 0 plus probability when z equals to 1 plus probability when z equals to 2, which is in this case 5 over 14 plus 15 over 28 plus 3 over 28. So which this one will give you 1. Okay, so since this one is equals to 1, so you can say that Z is a discrete random variable. So if it's not a discrete random variable, then you will not get a 1 for your answer. Okay, yeah, that is number 5. So you can realize that for the chapter that you learned before, right, like the permutation, combination, and the probability, actually you are still going to continue to use it in the chapter ahead, especially in this chapter. Okay, so let's move on for number 6. Okay, let's continue for the last 2 questions. Okay, a discrete random variable U has the following probability distribution, so find the value of K. So yeah, this is the same thing. I guess a lot of this question when they ask like find the value of K is basically using the method of like all the probability when you plus them together and you should be able to get 1. So for this one actually I want to introduce you so you might be having some probability distribution in this case, because you cannot expect that there is a formula that actually fits into all the probability distribution. So that's why they will be, sometimes they will have something like this, so meaning that with different value for your discrete random variable, you might need to use different formula for this. Okay, so for this one, when you want to find the value of K, then meaning that the sum of your probability for your random variable U equals to U, it should be equals to 1. Okay, so in this case it will be probability when U equals to 2, 3, 5, 7, 8, and 10. So 2, 3, 5, 7, 8, and also 10. Okay, which is equals to 1. Okay, so after you have written this, then you can try to substitute and find your function. So when U equals to 2, 3, and 5, you are going to use the first formula. So in this case, it will be U over 2K, your U is 2. So meaning 2 over 2K plus your U is 3. So U over 3K, and the U is 5. So 5 over 2K. Okay, and then plus, so remember 7, 8, 10, you are going to use this formula. So that's why 7 over 5K plus 8 over 5K and plus 10 over 5K, which will give you 1. Okay, so when you add up together, and you should be able to get 10 over K equals to 1. So K is 10. Okay, you might want to try this out by yourself. So what will be helpful in this case is you just change everything into decimal, then when you add all the number together, you should get a 10, then 10 divided by 10. Remember the K is at your denominator, not the numerator, so that's why it's 10 over K, which K is 10. Okay, so B, construct a probability distribution table for U. Yeah, so for this one you need to do it yourself. So what you can try to do is you try to write down first what is the new function, so that to ease your process. So K equals to 10, so meaning K is 10, so K times 2 you get a 20, so that's why this is basically U over 20. Okay, and here 5 times 10, which is U over 50. Okay, then you can try to build your table. Hold on. Okay, so let's do the table. Okay, so you will need U, small u, okay? And after that, you will need probability when U equals to U. Okay, then after that, you have 2, 3, 5, 7, 8, and 10. I'm just going to draw a simple one, so you please do a full grid one in your paper. Okay, 2, 3, 4, 5, and 6. Okay, so the possible value that you have is like 2, 3, 5, 7, 8, and 10. Okay, then now you try to substitute. So 2 over 20, which is 0.1, and then 3 over 20, which is, do I do something? No. So 3 over 20, I should get 0.15, and then 5 over 20, I have 0.25, and then after that for 7, so you remember you go to the second formula for 7 onwards. So 7 over 50, which is 0.14, 8 over 50, which is 0.16, and after that 10 over 50, you have 0.2. Okay, so you might want to check when you add it up together. So 0.1 plus 0.4, 0.5, 0.3, so yeah, you get a 1. Okay, so remember to check if you get a 1 here. Okay, so C, find the probability when U is greater than 4 and smaller or equals to 8. So for this one, meaning that what do you need to add them together is like when your U, okay, when your U is equals to, so bigger than 4, so 4 is not included, so you have 5, and then 6, 7, and also 8. Okay, so you just plus them all together, which is 0.25 plus 0.14 plus 0.16 plus 0.2, which, yeah, of course you can use the other way also. So like you want from here to here, sorry, did I do something wrong? 0 point, oops, sorry, I should 1, 2, 3, 5, 7. Where did this come from? Okay, so yeah, 1, 2, 3, correct? Okay, so 5, 7, and 8. I'm sorry, there's no U equals to 6. Then 0.25, 0.14, and 0.16. Okay, so you plus them all together, 0.3, then you get 0.55. Alright, okay, move on for 7. There are spaces for 3 more passengers on a bus, but 8 youths, 1 man and 1 woman wish to on board. So the bus driver decides to select 3 of these people at random and allow them to board. Draw a probability distribution table for Y, the number of youths selected. Okay, so in this case, meaning that your discrete random variable here is number of youths selected. So the same thing for the question just now. In this situation, when you're trying to model a situation in a discrete random variable, right, what you try to do is it will be helpful for you to list down what is the possible outcome first. So what's the possible thing for Y? So, sorry, selected. Okay, so you are going to allow 3 more passengers. So you have 8 youth, 1 man and 1 woman. So what is the minimum number of youth will be allowed on board? So it will be 1, because you need to allow 3. So you allow 1 man and 1 woman, then of course you need to plus 1 more youth, right? So you cannot have the situation where there is no youth selected, because if in that case, then you are not going to allow 3 persons anymore. So you will start with 1. Okay, which is like 1 youth, 1 man and 1 woman. So the other case is you can have like 2 youth and then 1 from 1 man or 1 from 1 woman. Then after that, the other one, then you can have, yeah, or 3. Okay, so the possible outcome for you is like 1, 2 or 3. Okay, so this question, the same thing, you can use combination to do that, or you can use tree diagram to do that. But for this question, I will recommend you to use a combination more than tree diagram, because why? Okay, you try to imagine this in your mind. Okay, so like if you were to draw this on a tree diagram, or even you don't draw it, but when you calculate the probability, what will come out is like you have what's that called? Okay, let's say I'm trying to put here first. Okay, so when you draw it, right, it will become like youth, and then man, and women. Then you split again. You can have the next youth or women or men or women. Then for this one you can have youth. There's no women already, right? Sorry, there's no men anymore. Then you can have women. Then after that, when you have women, then you have youth again. Then after that you can have another man. So if you have this, then of course the last one you need to have youth. So you can only have like one youth. Then after that, for this one, then you can have man again. Then you have youth again. So this is actually not an independent event. So if you want to draw a tree diagram, there's a lot of things that you need to think. And what you can realize here is, if let's say I want to find the probability, even you don't draw the tree diagram, when you want to find the youth equals to 1, right? So what are the possibility that you need to come up with? So maybe the first one for me to allow it is that I get one youth. Then I get a man. And I get a, so this will continue, right? Then I'll get a woman. Because I cannot have any man anymore. Then I will go ahead for the other one, which I have a youth, a woman, and a man. That's not finished yet. Then you still need to do, how about the first one is a man. Then the second one is a youth. And the last one is a woman. And also you can have the first one is the man, the second one is the woman, and the last one is a youth. And you can have the first one is a woman, the next one is a youth, and the last one as a man. Then also you can have the last one, which is women, man, and youth. So this will make like your working like very long, and there's a lot of things that you need to think, like do you actually like miss out anything or not. So like for this case, it will be much more easier when you use combination instead of this. Okay, but if you want to try out, then feel free to try to do it. Then I mean you should able to get the exact same answer one. Okay, so I'm showing you the combination way, so that will be much more easier. Okay, so probability for the number of youth equals to 1. So meaning what happened here, out from the 8 youths, I'm going to pick only 1. So that's why 8C1. Okay, then after that, because I pick 1 youth already, then I must take the man, I must take the women, right? So that's why I don't have any choices, which is 1. Or if you want to write down, then you can do 2C2 lah. Okay, so meaning the man and the woman, I'm going to pick 2 out of 2 of them. Then divide by the one that without restriction, so meaning out from the 10, I'm going to pick 3. Okay, so for this one, I'll be getting 8 times 1 and then divide by 120, which is equals to 1 over 15. Okay, so move on for the next one, which I have probability when number of youths equals to 2. So meaning out of the 8 youths, I'm going to pick 2, and then I don't care about the men and the women, I can take so either of them. So you can have like straight away times 2, or in an easier way, out from the 2, I'm going to select 1. Okay, so divide by 10C2, sorry, 10C3 again. So this will be 56, divide by 120, which is 7 over 15. Okay, then I'll do the same thing again. So for probability when youths equals to 3, so meaning that I'm going to pick all the 3 from the 8 youths. So 10C3. Okay, so because I pick 3, then the 1 man and 1 woman, I don't pick anymore. So that's why, or you put 2C0, you get a 1 also, it's the same thing. So this will be equals to 56 over 120, which will give you 7 over 15 also. Okay, so finish everything. So make sure that you must complete all the value, because yeah, you still remember the probability distribution must involve all possible values. So that's why you do this. Okay, then now you can try to build your table. So y, yeah, I'll just use hand. So please use ruler for your own. So probability y equals to y. Okay, then you have 1, 2, and also 3. So what is the probability? 1 over 15, 7 over 15, and 7 over 15. So remember to check when you add these 3 up together, then you should able to get 1. Okay, That's like pretty easy, right? Yeah. So for today's lesson, because it's like something new for you, so I don't want to, and we are now on quite on track already for our syllabus. So I don't want to burden you a lot. So that's why I split it into two. So which this is the first one, then the second, and the last one. And I want you to try you out. The number of question for this time is like a little bit what is that called, more than the usual one, because I think the question is shorter, but then I think it gives you a very good opportunity for you to do revision on the previous chapter that you learned, because everything that you've done here, actually you can see that it involves something that you learn in probability and permutation and combination also, so it can help you to like make sure that you still remember how to do all the two chapters which we learned before, and you can try to like understand the concept, like how to put everything together on the same page. Okay, so that's it for today's lesson. So remember to do your exercise and so on, and I'll see you on Friday.